Hello, in this episode of Exploring Rust, I'm going to look at modules. So my plan is first to look at modules that are defined just within main.rs, then look at modules that are defined in separate files, and finally look at structuring the program in such a way that we've got a library and then main.rs just calls some stuff from that library. This is my second attempt at recording this video. The last time was a complete disaster. I spent an hour on it before admitting that I was hopelessly confused and just had to give up. Hopefully it'll go better this time though. I think I understand where my missing piece of knowledge was last time. But just to reiterate that this isn't intended as a tutorial, this is just me learning Rust and trying to explain what I think I've learned. So I'm going to create a new, what should I call it, package. I'm going to create a new package now. Let's create a new package called animals. Go into there, and then I should be able to run it with cargo new. What am I talking about? I should be able to run it with cargo run. Okay, so it says hello world. Let's take a look at that. Here's my main.rs. So I want to try to define a module right here. Let's create a module called animals. So I use the mod keyword and I have curly brackets, and in there I should be able to put some function that I can use. So let's have a function speak. And in there I'm just going to say println I'm an animal. So I've now got an animals module. To use it, I can say use animals here in main. Now this isn't going to work, but in theory I would just say animals : speak. Let's take a look at the error message when we try to run this. So it tells me that if we scroll up a bit, speak is a private function. And actually one thing I'm going to do, because it cuts down the error messages a lot in demos like these, I'm going to put hash !allow round brackets unused at the top here so that I don't get unused variable and function warnings. Now the problem here is that things within a module are private by default. So I have to say pub function speak if I want to make this public outside of the module, and then I believe it will work. There we go, it says I'm an animal. Now this is actually a relative path. So we're in the crate root here, we're in the main.rs, and relative to that we've got animals defined here, so I can just write use animals. But we could also put an absolute path here which would look like this. Would have crate : animals. And now we've got an absolute path from the crate root, I suppose. So this also works. The level of privacy within modules is pretty extreme. So if I were to define a variable here, I've got to declare it pub if I want it to be available outside the module. I'm not completely certain how to do that, so I won't bother trying. If I want to declare a enum, again, same deal, it has to be declared public, and then the enum constants are public by default. If I declare a struct, the struct fields are private by default. So let's have a struct, which I'll call animal with a capital A, and in there we could have maybe name of type string and ID of type i32. So I'm not going to be able to reference this unless I make it public. Let's make it public. And down here I could then say let animal of type, what type should that be? Animals : animal be equal to animal, I've got to repeat, what did I call that? Yeah, the module's called animals, okay. So animals : animal, and I can define this in brackets. So I should be able to say string : from, let's call this animal Bob. Yeah, I've got to specify the field as well, so that's name. And then I could have, for example, ID of 7. Let's make this a bit smaller. I hope you can still see this. So I know for a fact that this isn't going to work, but let's try it. Yeah, one problem is I've missed off a semicolon. That's got to be here. Let's try again. And it tells me ID is a private field. So I've got to declare every one of the fields public if I want to actually use them outside the package. Now it should work. And there we go, it says I'm an animal. There's no compilation errors here. So if I declared, let's say, all of the fields public except one, I then have one private field, and I wouldn't be able to create a struct here there is a way to create a struct in such a way that you have default values for the fields. And that would work, I think. The problem is I don't know how to do it yet, so I'm going to just leave that aside. But you get the idea, they've all got to be public or else they're private by default. Now there are other ways I could do the import here. For example, I could say use animals ::speak, and then I believe I should be able to call speak like this. Okay, I didn't like that. What did I do wrong? Yeah, I shouldn't have round brackets there, only for calling the function. Now it works, and I've got I'm an animal again. Let's just do cargo format. Yeah, let's put some spaces in after my colons here. But this kind of way of doing it is considered not as good as this way of doing it, or we could just say use animals, that would be fine. But the point is to prefix functions with the module that they belong to, not necessarily the full path, but just the kind of module name that they're immediately in, because then you have an idea about where the function came from. And that's the same in other programming languages like C++. A lot of programmers will not just import functions. I think I've totally forgotten how the equivalent concept works in C++, but there is an equivalent concept that was introduced. And this is kind of the way of, it's called a namespace in C++. This is the kind of the recommended way of doing it. So you differentiate functions that might happen to have the same name, and you give whoever reads the code an idea about where that function came from by doing this. So we wouldn't normally want to do this. Another thing that we wouldn't normally want to do that we could do is, let's copy that. I could use a glob and import all the functions from animals, all the public functions anyway, and that also works. But neither of these is ideal. So let's look at defining a submodule. So we could have submodules in here, like I could have a submodule called cat. That could have whatever methods we want. For example, it could have its own speak method. So let's copy that and paste it in there. I'm a cat. And I'll have another one. That should be mod, sorry. Let's just copy that. And we'll also have a dog. And that's going to say I'm a dog. Now, how do we refer to these submodules? Well, I should be able to do, where actually are they? They're in the animals module. Well, they're directly in there. So I think if I do down here, well, I've already got use crate animals. But let's say I want to use the cat submodule. I could do use animals : cat with or without crate. And then I think I should be able to do cat : speak. Let's try that. So that doesn't work because the submodules, again, they have no visibility by default. They're private. I guess you can use them within the module. So you can use them within here. You're not going to be able to use them outside the module. So I need to make this public, and I also need to make dog public if I plan on using that outside the module. And now I think we should be able to use it with this. And now it works and says I'm a cat. I think there's one other thing I want to show you here, which is the super keyword. So let's imagine that within this animals module, we have a pub mod menagerie, and in there I want a public function speak, and I want that to just call speak in cat and dog. Let's make this a bit smaller. So how can I get from menagerie to cat and dog? Well, I sort of have to go up to the top level module, and then I can go down into cat and dog. I think. I don't know if there's another way to do it. Now, I'm not sure if I can actually call functions directly like this. Let's try it. Super : So that should get us into animals, and then we want to go down into cat, and then we want to call speak here. And I want to do the same with dog as well. Let's try that. Yes, that actually works, and it says, where's my I'm a dog? Oh yeah, I'm not actually calling this anywhere, am I? So let's go to, yes, I've got a menagerie speak now. Let's go down here and say use animals : menagerie. Then I think I should be able to do menagerie : speak. And it should say I'm a dog, I'm a cat. Let's maybe put a blank print line exclamation mark in there just to create some space in the output. Then if I run this, it says I'm a cat, I'm a dog. So you can use super. I don't know if it works with like use statements, but certainly you can use it like this to go up into the super module, the enclosing module, and then you're able to go down again. into like parallel submodules. I don't know if we could just call cat directly here. I mean cat speak. Let's just try it. Yeah, it doesn't like that. It just thinks it's not even declared. So let's get rid of that. So super is the way to do it, I suppose. I thought of something else that I want to show you here. I can't remember what it was. Okay, yeah, I just went to have a look at the documentation, and before I'd even started looking at it, my memory finally latched onto it. I want to show you re-exporting. So this speak function is within the menagerie submodule, which is within animals. So I have to access it via animals menagerie speak. Of course, I can import menagerie, and then I can just access it via menagerie. But what if for some reason I want to flatten the hierarchy a bit, and I want to be able to access this speak method directly within animals? And I have already got one there, so that also brings up a kind of naming problem, but I'm able to do that with a trick called re-exporting. So I can say here, okay, here we're within animals, so I should be able to access submodules. So I should be able to say use menagerie : speak, and I can use the as keyword as well. So as, I'll just call this multiple or something like that. Now this isn't quite right by itself. I just want to see what happens when I try to do this. Let's try to compile this and run it. So yeah, it doesn't object to that, but my aim here is to make this available within animals directly. So let's see if I can do that. Let's see down here if I can do animals : what I call it, multiple. I'm going to try running that. So that doesn't work, and it says the function import multiple is private. So I'm able to do this, I guess, if I want to use speak from menagerie as multiple somewhere in here, like further down. But if I actually want to use it outside of animals, I have to use pub, like that. And I think now it will work. So now it works. The output's not very clear, unfortunately. Let's just duplicate this, move it down a bit, and now I think you'll be able to see that it is actually working. So now we can call multiple directly from animals using this pub use syntax. And I've also used as. And this is called re-exporting. And funnily enough, I think all of this is found in Python. Very similar concepts there. Doesn't necessarily mean Rust was influenced by Python, because often these ideas are just in the air and multiple different languages pick them up. Okay, so I think that's enough of that. Obviously this is of limited usefulness because we've defined it all within one single file, but what if we want to use multiple files? Let's create a new package here. So I'm going to go up a bit and we'll say cargo new fruits and go into fruits. So I'm going to open that file from fruits. Let's close this stuff, go into fruits and source and open main.rs. So the simplest thing I could do would be just to put a module in its own file. Let's create a file in the source folder, which I'll call apple.rs. And in there, again, since I'm very unoriginal, let's have a function speak. Not that apples speak, but I'm just going to write in there, print line, I'm an apple. So we got a file called apple.rs. It's next to main.rs in the source folder. And how do I load this and use it as a module? One thing is I'm going to have to make that public. So let's go to main.rs, and I think I can do this. Well, there's two steps here. The first thing is, you see, when Rust, or Cargo I suppose, looks to figure out how it's going to compile your stuff, it only looks at main.rs, at least for a program with these settings, whatever's in cargo.toml, I suppose. It will also look for a lib.rs, which we'll look at shortly, but we don't have one of those at the moment. So it's only going to compile main.rs. It doesn't know anything about apple.rs, so I can't just use it. In order to be able to use it, we first have to, I suppose, in effect, declare that module, tell the compiler that it exists, and we do that by just writing mod apple in that case, so just the name of the file. Now it is going to compile apple.rs, and then to actually use it, we'd need a use statement somewhere above where we plan to use it. I'll just put it at the top here. So let's say use apple, or we could say use crate : apple. Doesn't seem to matter. Then I should be able to do apple : speak. Let's try that. So if I run this, okay, clearly it doesn't like that. I did something wrong. Damn, this is where I went wrong last time. I really thought I got the hang of this. Well, it says previous definition of the module apple here. So does that mean I don't need this second use statement? Let's get rid of it and see if it works without. Yeah, now it's actually fine. Look at that. All right. So I guess once we've declared this module, we don't then need to do use. Now, what if I want to create modules within modules? So I want to have submodules. We could just use a module statement here, but maybe I want different files for different fruits. So I'm going to right-click the source folder and create a new folder called fruits. And in there I'm going to create a new file which I'll call apple.rs. So that's another apple.rs, but this time within the fruits folder here, fruits directory. And I'll also right-click and create a new file called banana.rs, so we'll have two of them. And I'll put speak functions in there. So where's my original one? Here it is. So I'm going to paste this into apple.rs within the fruits subfolder. I'm an apple within fruits. And let's copy that. We'll go to banana.rs and have the same thing, but with banana in it instead. Now, here's the problem that I tripped up on last time I recorded this video. You could tell the compiler that fruits is a package if you want, but it's not going to let you use those files. It's not going to compile those files. Let's try this and see if that does anything. Doesn't even like that. It won't even regard that as a module. But it makes a helpful suggestion, which is the solution. What I have to do in here, in this fruits folder, is I have to create a mod.rs. So I'm going to right click, create a new file, mod.rs. Now in mod.rs, I suppose I could put stuff that I could call. Let's maybe try it. So I've got that speak function. Let's put one in mod.rs and say I'm a fruit. And if I go to main.rs, can I now use that? So let's try to say fruits : speak. So now I've got this folder fruits. Within there is a mod.rs. And within there I've got a speak function that says I'm a fruit. And I think this should try to load that directory as a module. It expects to find mod.rs in there. And then the contents of mod.rs I think should become the content of the module. So then I should be able to call this speak method in this case. Let's try this. Yeah, that works. It says I'm a fruit. But what I really want to do is use the code from apple.rs and banana.rs. So let's go back to mod.rs, and I believe I should be able to do this using a couple of re-export statements maybe. So in here I could say I could use a relative module path, I think. No, wait, I don't want that, do I? I think what I want is to declare these modules. So if I say mod apple and mod banana, okay, so now when Rust tries to compile main.rs, it's going to look and see, okay, there should be a module called fruits. It looks for a fruits.rs, it doesn't find that. It finds a fruits folder, and in there is a mod.rs, so it goes ahead and compiles that. But when it compiles mod.rs, that brings in mod apple and mod banana, which are in the fruits directory. And then I think those should be compiled. Whether I can actually use them is another question. Let's see if it's okay with this. So yeah, I've got a couple of warnings, but it did actually run, so that I haven't done anything actually objectionable here. What I want to do is at the top, I'm going to write square brackets, and before that we're going to have hash exclamation mark and allow unused, because I don't want to see these unused warnings. They drive me crazy when I've just got some demo code. So I think now if I try to compile it, we shouldn't see any warnings. Can I actually access code from these submodules now? Let's try fruits : apple : speak. We'll do the same with banana. I don't think this is going to work, but we'll try it. So if I run this, it tells me I've got private modules. And the problem here is simply that I need to use pubmod to actually make these public, to actually publish them, in other words. So now, if I try to run it, let's run cargo format as well. Cargo run, and it says I'm an apple within fruits and I'm a banana within fruits. So we've successfully created a couple of submodules within the fruits module. Now the final thing that I want to attempt in this video is to create a program that consists of a main.rs, so it's going to be an executable, but it's also going to have a library in it. That library might load modules as well. So most of the code or all of the code is going to be in the library basically, and we're just going to use main as a way of running stuff from the library in essence. So let's go back to the terminal, and I'm going to cd out of fruits and do cargo new, let's call this locations. And if I go into locations, I can do cargo run. There we go. So I can create a pure library with -- library with cargo run, or at least I think that's what it was. And I did try that, and it created like a sort of test stub, but I didn't really figure out how to run that, and I've just kind of left that aside. Because at the moment, I don't even know really how to link libraries. That looks a bit complicated, and it's not my priority right now. So what I want to do right now is just create a program that just uses a library that's within the package that I've created, in this case the locations package. So I'm going to close the files that I've got open at the moment. I'll minimize fruits here, and let's go into locations source main.rs. So to create a library that's used by my program and could be used by other programs, all I have to do is right click the source folder and create a new file, lib.rs. So these are the two files that Rust will try to compile by default anyway, main.rs and lib.rs. So this is going to be automatically linked with my program. And let's have a module in here. I won't do anything fancy because we've just been all over that in ad nauseum. But I'm going to right click and create a new file, and I'll call this, let's call it cities.rs. And in there, let's have, I don't know, what should we have? Let's have a public function called show, and that's going to do print ln ! And let's put in there Rome, Paris, London. So how would I actually use this cities module from within lib.rs? I guess I have to say mod cities, right? I've got to load it. And then I could have like stuff in here. I could have functions in here, modules in here, whatever. But now I do have to confess to some uncertainty. Like if I put a function in here, how would I load that? But I'm not sure that I even should be doing that. I think maybe if we declare mod cities here, Rust is going to compile lib.rs by default anyway. Then it should see this, and it should try to compile this. And then I should have a cities module that I can use in main.rs. That's my working theory at the moment. Let's try it. You can put these module and use statements basically anywhere in your code, I think. So I should be able to do use and then either cargo, : or even without that, I think use cities. And then I should be able to do cities, : what do I actually call that? Show. So let's write show there, and let's see if this works. So I'm going to go to a terminal. I think this is going to be like 50-50. Let's run it. It says unresolved import cities, no external crate cities. It's also telling me that show isn't used, I suppose because I didn't turn off warning about unused functions and variables within that library. Okay, I've just checked my notes and I forgot something pretty basic. So again, we have to deal with the fact that everything is basically private to do with modules unless you make it public. So in lib.rs here, I need to say pubmod cities, which I guess is short for public, but you can think of it as publishing this, making it available outside the library in this case, I suppose. So then in main, I've got use cities show. Let's try that and see if that works. Okay, now it doesn't work, but it's got a really helpful suggestion. I forgot that it says I should consider importing locations : cities. Locations is the name of the package that I'm in. So let's try that. I'm going to write here. I just want to try one thing before I do that. I don't think I could use crate cities because the crate root here doesn't know anything about cities. I actually need to say that I want to use cities from the actual package I'm in, I think. Let's just try that though. Yeah, that doesn't work. So let's change this to the package name, which I specified with cargo new. I'm going to write locations cities here. Let's try that. And now it works. We've got Rome, Paris, London. Amazing. So if I take a look at what's been generated, okay, there I've got my cargo.toml. I don't know what cargo.log's for. In source, so there I've got cities.rs, lib.rs, main.rs. Let's go into target. So cd target and take a look at that. There I've got a debug folder, some sort of cache thing as well. So in debug, so here I've got my binary program. That's raw binary code, just like if you'd created this in C or C++, running directly on my CPU. I've got this, which I think is debug symbols. If you create a C program, don't you get a locations.d if you compile a debug version of it? Can't really remember, but I wouldn't be surprised. But what we've also got is this liblocations.rlib. So prefixing libraries with lib is a common convention, and we've got rlib rather than just lib or something because it's a Rust library. So we've actually generated a library. It's a debug version because I haven't built the release version, but we've got a library that's generated along with the binary. And of course I could just run the binary here with /locations. Okay, that's it for this video. I'm amazed that I've got through it. As always, I'm going to write this up and you'll be able to find it on blog.caveofprogramming.com. I'll put a link to the code on GitHub there as well, and you can watch this video there without being interrupted by ads. So until next time, happy coding.